Hello and welcome. In this video I'll be teaching how to evaluate triple integrals. So when you start, there's going to be very easy problems just like this, and what you're going to want to initially look for is that inner integral, this one right here. And see, they all pair up just like that, and that is the exact order that you're going to want to evaluate them. And that's really the biggest trick to doing this, is you start on the inside and you work your way out. Now there are ways to switch up the order, but that can be very difficult. So it is, normal, especially when you're just starting to learn how to do all of this, that the integrals you'll be given are already in the order they need to be in. So for this first one, we start with this inner integral, and just start by taking the antiderivative with respect to z, so it would be 9xy z squared over 2, evaluated from 0 to 2y, and of course you'd still have your dy dx, and you'd sort of just treat this like you're doing one single integral at a time. So you'd take the 2y and the 0, put it into this. Of course, you can skip the 0 because you can already see it's gonna be 0. So you can just kind of skip that step and go 9xy 2y squared over 2 dy dx. Then we're gonna simplify that down, make it easier. And we're gonna get, so this is gonna turn into 4y squared, and the 4 can cancel out with the 2, so you'd only have the 2, so it'd be 18xy, and then since this is squared, you multiply that into this, e to the third, oh, not over anything, sorry, there we go, dy dx. Then we take a look at the next inner integral, be another right there, and we are going to integrate with respect to y this time, so it'd be 18xy to the 4th over 4, just like any other antiderivative. This time x to 3x, and you got to remember the dx. And then this time we're gonna have to do the bottom bound too, because it's not just 0, it won't cancel out. So we're going to do 18x 3x to the 4th power, right there, over 4, minus 18x x to the 4th power over 4 dx. Now this is gonna simplify down real nice, and we're gonna get, sorry, I had to look at the what 3 to the 4th was, and we're gonna get, I'm taking a little bit of a leap here, but if you do the calculation, this is what it'll come out to. X to the 5th, because you're gonna have that x to the 4th multiplied into the regular x, so you're gonna have that minus 18x to the 5th over 4 dx. Now you can choose to either subtract both of these, or we can leave it like this. Personally, I just multiplied by 2 here, got the common denominator, multiplied by 2 up top, and it simplified down to just a nice easy 360x to the 5th dx. So great number, worked out perfectly. All right, and then just the last integral, so it'd be 360x to the 6th over 6. Now you can see right here, this is gonna simplify down real nice. 0 to 1 be 360 over 6, because the 1 to the, here, I'll just put that in there. 1 to the 6, and then the 0 we don't have to worry about at all. Come right out to 60. That is a nice, simple, great example of how to do a triple integral. And now here is the second harder integral. And we're looking at this, and just like the first one, we start inside and we work our way out. So looking at this one, we see there are no z's here, so it's gonna be a real nice first antiderivative. It's just gonna be 63z. Real nice from 0 x squared plus y squared. Oops. All right, and then we're gonna take that and just plug it right in. So 63, and you don't really have to worry about the 0 in this case, because just like in the first integral, you just don't need to have the 0 in there, because if you plug in 0, you're gonna get 0. So it just works out perfectly just like this. And now, if you are looking at this, we're gonna simplify this first. Get it looking nice and pretty. If you're looking at this, you're gonna see the reason why it's this is harder is, well, it looks harder because of, there's two variables here. That doesn't actually make it harder, because the actual f function is, just an integer. It's just a number. So it makes it really easy to integrate that first integral. But the actual problem isn't the actual aren't the antiderivatives or the integrals. It's going to be factoring, because we're going to have this be an x to the third on our next antiderivative, and we're going to have to put in 1 minus y squared, which is going to make it very hard to factor. So we're going to get right into that right now, though. So, and then the antiderivative of dx, we're doing the integral right here, this next inner one. So it's going to be 63x to the third over 3 plus 63y squared, and that doesn't have an x, so we're going to put it right on there. From 0 to 1 minus y squared. Always got to remember the bounds. Always very useful, very helpful. And then we're just going to plug those right in. And this actually simplifies down to 21. We're going to have 1 minus y squared, 1 minus y squared, 1 minus y squared. This is going to make it a lot easier to factor like this. And plus 63y squared, 1 minus y squared, right at the end there, dy. Let's just start factoring. So we're going to have 21 here, and we'll do these one by one. So 1 minus, you're going to have 2 negative y squares, so it's 2y squared, and then double negative, so positive y to the fourth. And we're just gonna bring that right on down so we can set up the next step. We'll factor this in, 63y squared minus 63y to the fourth. We'll do a parenthesis, dy. And then we're gonna finish up our factoring, and things should start to cancel out. So we get 1 minus y squared minus 2y squared plus 2y to the fourth, and then plus y to the 4th minus y to the 6th plus 63y squared minus 63y to the 4th dy. Now you could leave this just in here like this, or you could just start, you know, putting in 21, see if that cancels out with any of these. That is what I am going to do right now. 21 minus 63y squared plus y to the 4th minus 21 y to the 6th. Now the y squared, I just put these together in this, make it easier. And then we're gonna have plus the 63y minus 63y to the 4th. And as you can see here, there are some things we can cancel out. Excuse me. We can cancel this out. Cancel that negative as well. We can cancel out this. And look at that. Just like that, we have a nice, good-looking integral here to solve. Simpled out perfectly, or canceled out perfectly, right down to this. And now we'll just take that last integral. 21y minus 21y to the 7th, 7, from -1 to 1. Now, we are going to have to do both bounds on this one. So that is key. And if you haven't noticed, the order of integration here is different. It's dz dx dy instead of the normal dz dy dx, which is this early on in Calc 3, when you're just starting to learn triple integrals, that is how it will be. They will give you the correct order of integration every time. Later on, though, you will learn how to switch these around. You'll learn how to figure out the bounds and rebind the integrals so that you can have dx, dz, dy, or you can have dy, dz, dx, any order. And you will get the correct answer every time. So that is really, really interesting. And yeah. So let's finish this problem though. Just plug in 21 1 minus 21 1 divided by 7 minus 21 negative 1 minus 21 negative 1 to the 7th. These are both to the 7th over 7. Whoop. There we go. So we're going to have 21 minus 3 minus negative 21 plus 3, because that's an odd power, so that's going to stay negative, making this all like that. And then you're going to have 21 plus 21 equals 42. So, as you can see, that one's a little bit tougher, but definitely doable, All right, so let's get into the next one. Now this is a story problem. This one's a little bit more difficult. We're actually gonna have a graph for this one. So that'll be interesting to see how that comes out. Now for this one, a solid in the first octant, so the first positive, everything's positive, the z, x, and y is all positive, is bounded by z equals 4 minus x squared. So that's going to be a sort of parabolic shape, line, more like line. And then x equals y squared. So what we're going to do right away is y equals x right there. So in this one, we're going to have to try and find the bounds by ourselves, which is always easier when you draw a picture. So that's what we're going to do. And since it is in the first octant, we're going to be able to draw a picture only using the first octant. So then we have y, x, z. I'm sorry, I'm not the best at drawing, but I'll try and make it work here. So, yes, I switched this to y equals the square root of x out of ease, but you can do the exact same type of graph. If you remember that how the y equals x squared is, it's that parabolic shape going this way. It's the exact same thing, but down the x-axis this time. So you're gonna have that type of shape. And remember, this is like a plane, so it goes all the way up the x-axis. And then with z equals 4 minus x squared, you're gonna go 1, 2, 3, 4 up the z-axis, and then you're gonna have that x squared shape. So it's gonna kind of cascade downward, and on top of the on top of all this, it's gonna cascade downward, just like so. You're gonna get a bunch of these cascading down, just like that. 4 minus the x squared, so you're gonna have that parabolic shape. That's actually gonna, if you remember, if you plug in, you can plug in numbers here, and if you plug in 2, that's gonna be 4 minus 4, so z is gonna equal 0, and that's gonna be right on there because of the 2. So this is the sort of shape you're gonna have is right in here, and it's just bounded right up in here, if you can imagine that. It's a little bit hard with my picture, but there's like a little shape here. I don't know exactly what type of shape that'd be called, but seeing it here, we can kind of find our bounds. So with this, we're gonna want to start with our dz first, because we want to smush this into the xy axes. So we're gonna just set up our triple integrals here, and it's just 1. 1 is the default for volume. If you're finding volume, you'd always use 1. So that's always a great start. And if you're looking at the z-axis, you're coming from the bottom up, right? To try and find that bound. So the first thing that you hit is right here, this shaded area, which is z equals 0. And then as you're coming up, you hit this. This is the top bound. This shape here, or that line, that plane, which is 4 minus x squared. And then you would smush that down into the xy plane here, x, and that's cut off at 2. So this is the region here. And now you'd be looking for dy in this situation. You'd be looking for dy, so you wanna start going up to try and find that dy. So kind of looking at this, it's mostly it's whatever's easiest, and what looks easiest in this situation is definitely having the upper bound be the y that has the variable in it, instead of with x you'd have the lower bound be it. But either or, in this case I prefer to go dz dy dx whenever I can, and because that is the default. Like, that's just what you start with to see if you can do it, and if you can't, then you try and pick and choose or switch around certain the dz, dy, dx to get your order of integration. And what we want to do here is we're looking up to see what that first y hits at first. And it hits 0 at first. That's our bottom bound. And then coming up, it hits this, which is the y equals square root x. So that is always important to find your anything with an x and a y in it. You're going to want to find it with either z, if it has all three, or if it only has x and y. You're always going to want to find it with y so you know what the graph looks like. And then looking at x, just the lowest and highest number it can be, 0 and 2, because that last integral cannot have a variable in it or else it will not be solvable. So you can have 2 variables in this. You can have the back 2 variables be in that first integral, and then the second one you can have the last variable be in it, anywhere in it. And then the last integral cannot have any sort of variable in its bounds. So now looking at this, we have it. We have our integral. All we have to do is solve it now. Looking at it, just gonna put a z right in. Just like that. It's perfect. And then we go ahead, plug in 4 minus x squared dy dx. Once again, we do not need to do the 0. There is no constant here, so it does not matter. It's not being added or subtracted by a constant, so it doesn't matter. Now looking at this, we have our dy we're going to do next. So that should not be an issue. Be 4y minus x squared y dx equals from 0 to that. Just go ahead and plug that in. Now, for this one, we just want to simplify this. This is the same as x to the 1/2. So it'd be x to the 5 halves dx. Now, we can do this. This is a bit harder of a integral to solve, but we'll get through it. And so for x here, we're gonna have this. This is x to the 1/2, so it would be x to the 3/2, 2/3 times 4. You keep that 4 there, and then the 2/3 comes from flipping this right here, because that is what you're supposed to do with antiderivatives. Because of the chain rule, you flip it, put it down. And then with this, it'd be 2/7 x to the 7/2 from 0 to 2. Now, just like in the last few, don't have to do 0. You rarely will have to do 0. So let's plug in 2 to the 3/2 minus 7x. Oh, not x. 2 to the 7/2. I am going to need my calculator for this one. Let's see what we get here. 2 to the 3/2. Actually, we can just leave our answer like this. This is actually a perfectly good way to leave our answer, because it's a nasty decimal is what you get. And this looks all right. Very acceptable answer. And that's all the examples I have for today. Hopefully you learned something, and thank you for watching.